Students alleged that was ironic.
Oh, really? Which one?
I tried to defend you, but I was outmanned. So I think we talked also yesterday about how, you don't want to go surfing at the pit after the first rain because the ear infection, because they're flushing all the dukes. And then we talked about this very large watershed. Did I allege that it's the largest? I hope not, because I did some research, or rather I forced a student to do research. The Mississippi River is the 6th largest watershed in the world. Still pretty big. The largest is the Amazon. And I want to remind you of something that I tried to say yesterday, because it'll come up again. Please look up. It's not that all of this is going to put, like, baby Ruth in the pool in the Gulf of Mexico. We're not so much worried about directly biodegradable waste entering the ocean. What we are worried about is those biodegradable wastes have biodegraded along the way and a bunch of nutrients come out of the Gulf of Mexico. Like a big hit of fertilizer. You remember, we talked about this. It's called eutrophic, high nutrient load. Can be natural. I think Carlton asked me that question yesterday. Yes, it happens in nature all the time. But when you have a lot of additional inputs of nutrients from human interactions, then that's going to add more fertilizer to the system. Yeah?
So, like, the question asks that, or is that the problem was that, like, fish can asphyxiate because of its dumps all in the same spot, but is that because the decomposition takes away the dissolved oxygen, or because all of a sudden there's, like, a lot of algae and stuff?
I will clarify, because both of those are true, and we skipped a part of the first, and I still haven't said the second. Kupiak says, what's this got to do with fish? Here we go. Nutrients are just, they're what make you beautiful, unique, special little snowflakes. Nutrients are critical to all life. So when you add fertilizer to the water, that's not a problem. That's good news. And productivity swells, and consumption swells. The problem is what happens when those nutrients run out. Then you starve the algae and they die, which starves the consumers and they die. And when you get all that dead stuff on the bottom, then you get a dead zone. The fish asphyxiate because the decomposers are using up all the oxygen to eat the stuff that dies after the fertilizer. You see, fertilizer is like a big party. It makes more food web. But everybody knows the worst part of a nice party is cleaning up at the end. So after that fertilizer boost is tapering on the backside of the fertilizer curve, when the fertilizer starts to run out, then everybody starves and dies, and then their things starve and die, and they starve and die, and starve and die, and you get all this die-off because you've restricted nutrient supply. So eutrophication in the ocean is not the actual problem. It's the tapering of eutrophication which causes the problem. Die-off, decomposition, dead zone. Got it? That's ocean. Okay, all right?
So if we just continue to keep the level of agricultural runoff and stuff in the Mississippi forever, then you wouldn't have to deal with it because it would
probably not
always be eutrophied.
Essentially, yeah. Yeah, I mean, if you could turn that into a consistent trickle, that would not necessarily be a problem. We're going to talk about this soon, but Santa Barbara's wastewater treatment facility dumps out nutrients into the middle of the Santa Barbara Channel every day. And because roughly the same number of people flush the same number of toilets every day in Santa Barbara, give or take a small variance, we keep putting the same amount of nutrients in the Santa Barbara Channel. There's no dead spot in the Santa Barbara Channel.
I guess what I'm saying is that if there's a perfect balance of amount of nutrients to natural aeration of the water, and then you put in a lot of nutrients, even if that nutrient flow doesn't stop, won't the air supply run out because there's so much more productivity in the water that's taking up that air, even without the biodegradation problem?
Yeah, I'm sure it's possible to overdose nutrients. Well, no, because if you overdose nutrients, you're going to get a whole bunch of life.
But do they aerate the water?
Yeah, I mean, I guess aeration may still be required. At some point, there must be a stagnant water tipping point where more fertilizer doesn't make more life. Yeah. You can think of swamps, like. But I think that you would get to really, you'd have to really push the nutrient load. So, in lakes, though, things are different. Because when you add a bunch of eutrophication in a lake, different problem, you get this, which is like a steady state burst of life. In a lake, you get these floating algae mats. The problem here is that the floating algae mat prevents oxygen exchange and shades out the photosynthesizers at the bottom that produce dissolved oxygen. So in a lake, the fish asphyxiate because this blocks airflow and prevents photosynthesis down below. Remember, it's a different problem. BT Dubs, I don't know if you know this, but at the end of our period today, we're probably going to have a fire drill. I don't know if I got the timing right. It might be period 4. What? All right.
Was that stuff good or bad?
Still bad. Because remember, stop. In case it is today, I still want to rush. I don't think Blondell has ever been wrong, but just in case, I'm still going to rush. The natural state of a lake is oligotrophy, which means low nutrient. So overloading the nutrient supply, that can be really dodgy. See, lakes are usually pretty barren. No. So what I would like to talk about now is a study goal that I just skipped. I'd like to talk about study goal number 27. Where does coliform bacteria come from? What? Poop. Yes. Belfiore nailed it. Coliform bacteria pretty much only comes from one place, poop. When you hear people say food poisoning, let me remind you that food's not poisoning. Food is the opposite of poison. Food is good for you to eat. Food poisoning should be renamed. Poop poisoning. There's poop in my food poisoning. Poisoned food. Poisoned by poop. But people don't like to say that around the water cooler. I got poop in my mouth, so I had to stay home a couple days. Doesn't sound quite right. Yeah, the chef put caca in your spaghetti or something. You know, like the whole pooping while holding a bucket situation. That's because you've got the wrong bacteria in your stomach and your body knows it. So you have to evacuate digestive system. There's this... Thank you very much. Oh, he's here. Yeah, paper? It is not here. Right. He's here. So you want to pass this back to Diego's desk so he can find a way? I wish we could talk more about that because we just had an academic senate meeting about this paper slip thing. Okay. Coliform bacteria means there's caca in the water. There's this report you can get of water quality testing at county beaches. And when they have a dangerous level of coliform bacteria, that means there's a lot of caca in the water. They don't like to say it that way, so they say, you know, pathogen load is high, or coliform bacteria count is, you know, in the red. But they could also just say, there's dookie in the water, don't go in there. Yeah.
Isn't the pit like one of the top 10 dirtiest beaches?
That's right. That's right. Oh. There's two things that happens in the pit. Number one, you know, there's a lot of poop making it into the water. That's an urban watershed. Because it's an urban watershed, you know, you've got like high school kids barfing behind the bushes, and you've got the occasional busy mom or dad who leaves the dirty toilet, you know, on the trunk of the car and then drives away, and that goes into the creek.
What?
Whatever. What did I say?
A busy mom or dad.
Oh, dirty diaper. I meant dirty diaper. Yeah, it might be.
The dirty toilet.
Exactly. Yeah. It's very distracting, okay, doing the diaper thing. Anyway, you've got poo-poo in the water somehow. And you know the pit has something else. A second problem. You know, the pit. That giant pool of standing anaerobic oxygen-poor water. Right before it goes to the ocean, there's that slough that occasionally gets kind of foul and foamy. If the timing is right, that water will go anaerobic. And anaerobic, like your intestines. So the bacteria is like, oh, I'm home. This is a colon. And they start breeding. And then they get flushed out to the ocean, and Kong's like, ooh, surf's up. And he's got dookie in his ear.
If we put one of those things that have ECS beans that goes through.
Yeah, bioswales will help out compete this. By the way, you could go even simpler. You could just aerate the slough. But you know, anaerobic water is kind of natural. It's supposed to be there. Those are natural features of a wetland. You just got to keep the dookie out of the water sometimes. So let's get the dookie out of the water. Wastewater treatment. These are study goals 34 and 35. I know I'm skipping around. Let's just assume, for the sake of conversation, that your house is as dirty as the next. So we don't need to be shy. What sort of stuff gets flushed out of your house? What's in the sewage?
Babies.
Soap? Shampoo?
Food.
Food?
Human.
Hair? Quite a bit of hair. Lots and lots of hair.
Excrement.
Excrement in all of its varied and beautiful forms.
Hopes and dreams.
Some hopes and dreams. Some feminine hygiene. Some used rubbers. Some latex gloves.
Ew.
Some occasional clothing. Some whatever your 4-year-old wanted to throw in the toilet. Cell phones and wallets and Legos and goldfish.
Diplomas.
Little baby pet turtles.
Oh, they can swim today.
Yeah, some stashes. Some stash bags. You're like, oh my god, it's the cops! And it's like, oh, it's just a pizza guy. And it's like, oh, dang it. And all the time.
Balloons.
Apparently it's like, apparently it's more common than you might think. I mean, think, like, what are cops doing all day? They must knock on a few doors, and statistically, how many people are flushing a stash when a cop knocks at the door? That's got to be a couple of days, maybe? So what's this? You've got two jobs. Remove the trash, like garbage, grit, and sludge. That just goes to the landfill. Some places will digest the organics into methane, like the Santa Barbara wastewater treatment facility. We take all of our sludge and grit and solids and organic stuff, and we put it in a big anaerobic digester, which is basically like another gut. And anaerobic decomposition makes methane, CH4. So they have generators and they have fuel cells that run on methane. And they make all their electricity using the farts that weren't made by the gut in your bacteria, by the bacteria in your gut. Pretty much. They, it's kind of hit or miss. The problem is that the people, like, those were like cutting edge fuel cells, and so the math wasn't quite right on the plumbing and the maintenance and stuff, but it has periods of self-sustainability, yeah. The carbon that you didn't get to expel from your body is further digested by the bacteria you expelled from your body, plus all the other organic material in the waste stream, like the stuff out of your food disposal and your soaps and your washing off barf on your clothing and stuff. All that gets digested by bacteria in a big tank, and then they part out methane and they run the power plant on that. Are you being grossed out?
No.
Good. The other thing that happens, of course, is we got to treat the organics so that we can discharge as much water as possible to the environment. Maybe the ocean, maybe a river. So let's do that. There's the municipal wastewater treatment system. That's what you see up here. Essentially, all places, please look up, do this. And almost all places in the first world do that. But you only do this if you're discharging into a river. If you're going into the ocean, usually you don't do that. So check it out. Number 3 has an asterisk because it's optional, mostly for freshwater discharge. Santa Barbara doesn't do tertiary treatment because we've got this big giant ocean. We just disinfect and discharge. In Santa Barbara, we put some of the stuff into reclamation, like reclaimed water system, the purple plumbing we talked about, water recycling. And some of the stuff we just put out into our closest waterways. In Santa Barbara, that's the ocean. In other places, that might be a river or something. So, primary is physical, secondary is bacterial. This is filtration, this is digestion. So in primary, please look up, there are 3 options. The screen for big stuff, like bigger than a penny. That's where the Ziploc bags go, the t-shirts, the fem hygiene, the used condoms, the miscellaneous garbage, the big chunks of broccoli, whatever. Big stuff. Then, all the grit, like there's a shocking amount of sand in wastewater. Not just because we have a beach, but like when kids go play in the dirt, the stuff that sticks in their shirt is usually sand. So you wash laundry and that's a bunch of sand. And you wash off your lettuce and that's a bunch of sand from Fresno. And then you wash off your feet and that's a bunch of sand from wherever you were walking that day. And you wash out your hair and that's from like wherever you laid at the beach to get a tan. And it's just a bunch of sand. So that's the grit chamber. Then the sludge, that's organic stuff. That settles more slowly. A bunch of seeds, like strawberry seeds, blackberry seeds. Everybody knows that you don't digest the corn. You know what I'm talking about. All those seeds, like the skins of beans, like black beans and pinto beans, like those skins. And here's a shocking one that a lot of you probably haven't thought of. Your dukes are like 10 or 20% bacteria by volume. You know, your gut is like a giant ecosystem of bacteria. And so, in the sewage system, the seeds don't make more seeds. And the black bean skins don't make more bean skins, but the bacteria go nuts in there. And you know, and all the plumbing from your house, under the street, out to the thing, along the way, the numbers of bacteria keep growing and growing, and the dead bacteria all settle down as sludge. Now watch this. We're going to bring those back. Check this out. All that sludge gets pumped back into secondary because we need those bacteria. In secondary treatment, we're going to break down the macromolecules into their basic nutrients. This is recycling. This is decomposition, like, you know, underneath trees. So you have to add oxygen so you can decompose organic molecules like sugar, fat, protein into the basic building blocks, in other words, the fundamental nutrients, nitrogen, phosphorus, potassium, carbon, hydrogen, oxygen, calcium, sodium, whatever. Yeah?
So it's the bacteria doing the filtering?
Yeah, the actual decomposition is all the bacteria that you delivered when you flush your turds. And the wacky thing is, you see this part, the sludge, sediment coming back and activating with more air. That is the secret of wastewater treatment. Like, the majority of the engineering and the nerdiness and the science and the test tubes and the lab coats is about getting today's dookie bacteria to last until tomorrow so they can eat tomorrow's dookie. It's like this giant bacterial husbandry experiment where they do all this like plumbing and measuring and suspension and oxygen levels and temperature adjustments, flow rate, water testing, all kinds of nerdiness, just to make sure that they're like raising a little colony of bacteria, because tomorrow morning at 7 a.m. on average there's going to be this tidal wave of turd. It's a beautiful thought, right? Yes?
Were we using that turd as fertilizer at one point when we stopped?
Yeah, so historically, the turd itself is not a fertilizer, but that sludge, that would be fine fertilizer. You know, it's seeds and bean skins and dead bacteria. That's all organic.
Why did we stop?
We stopped because now your waste stream, your urine and your feces contain tremendous volumes of pharmaceuticals that are not treatable in this system. They also contain huge volumes of heavy metals because we eat so many peak predators, you know, biomagnifiers, the tuna and stuff like that. Yeah.
How long is each section?
Somewhere in the minutes to hours range. So the turd you dumped this morning is probably like the water that was carrying the turd you dumped. That water on average is almost out of the wastewater treatment plant by now. Almost. I think that the average residence time is 3 to 4 hours at the plant and 4 to 6 hours in the plumbing. But then, of course, they have to nurture the bacteria, snowball through the day, so that they can digest all of tomorrow's dookie.
So it's constantly running.
Constantly running. The one time it's not constantly running is when jerks hook up their rain gutters to the sewage. That's a crime. And you will get tooled big time. Because the same amount of people flush the same amount of toilets on average every day in Santa Barbara, unless all the runoff from here goes down my toilet too, you know, through the sewage. So on storms, they can't treat the normal flow rate because there's an extra 1 billion gallons of rainwater included in the waste stream. And what else are they going to do with it? They don't want to like back it up out of your toilet. So they have to flush untreated sewage into the ocean. The only time we put untreated sewage out to sea is when the wastewater treatment facility is overwhelmed by illegally diverted rainwater and sewage. Lazy plumbing, like if you've got a big old house and the rain gutter goes off the back, we got to make like rain gutters and underground pipes and French drains to get it out to the street or whatever. Or you can just go, screw it, I'm going to put it into the sewage. And so just literally, it's usually shady plumbers. Like, you hire a plumber that's like, oh, dang it, I can't, you know. I'll beat her bid, I'll do it for $100 less. And you just don't do that last bit and put it in the sewage. My parents bought a house. The house that I now live in had rain gutters going into sewage. Yeah.
So they can track it now.
No, when we inspected the house before my parents signed the papers, they're like, oh, you're going to have to fix that. And the previous owner was like, I don't know what that is. And so I don't really know whose fault it is, but anyway, it's common. Like if you go check at your house, you might have rain gutters going into sewage. They use smoke tests. So they light a fire inside a sewage pipe, and then they look to see with binoculars if there's smoke coming out of somebody's rain gutters. You understand how that works? Because the smoke wouldn't come out of your toilet or your because you have a P-trap, little thing full of water under normal household plumbing. So they look for smoke coming out of people's, and they go, oh, and they drive over and they tool you. It's crazy. It's super crazy. Yeah.
When I was in Oahu a few years ago, it was raining so much that they were just dumping raw sewage into the harbor. And there was a guy swimming and he straight died within 24 hours. Crazy.
That is super narnar. That's super narnar. Sorry to hear about that. Yeah.
I was in agriculture working in
Gray water? Irrigation.
rainwater.
Rainwater? What do you mean? I'm sorry, I don't understand.
Like, if we just had a ton of buckets outside of our house and collecting all the rainwater that we
Oh, well, if you had enough buckets, you could... No, hold on, stop. I got to go somewhere else, so hold on. If you had that much, you could literally use that to flush your toilet, for example. Like, you realize that the toilet tank is just a bunch of water in a bucket, and when you flush the toilet, there's no magic. It just lets that go into the toilet, which goes and that flushes away your stuff. So you can just walk up with a bucket and pour it in, and that's flushing. It flushes the same way. It even makes the sound and everything. You could use that for, every B-rate water usage. So like washing the lawn, washing your car, hosing up the driveway, I don't know. You could drink it, by the way. It's just usually people don't like to. Yeah.
Wait, why does it say in like the reader or something that you put a brick in your tank?
Yeah, because your tank is not smart. Your tank is just a volume of water. Up until the 80s or 90s, all of our toilets were 6 gallons, which is more than this. Now our toilets are 1.5 gallons by law, which is like this. But if you have like an old school antique toilet, like your house was built a long time ago and they haven't replaced the toilets, the tank is Hugo. It'll hold like more than this volume of water. But you don't need that much to flush a turd. So you can put like bricks in the toilet tank to displace water. So there's a smaller volume of water, so when you flush, it's just a couple gallons going in. But don't do that with a small low-flow toilet, because that won't, your gook will hang out. Okay. Quickly, there's another option. If you don't live in a place that hooks up to sewage, you can do septic. And a key fact for you to know is that the flow rate of a septic system is key. Because there's no fancy anything. A septic tank is just a place where you put sewage in and you're hoping water will come out clean. And there's no technology or filtration. It's just about the flow rate. Watch. You want to get primary on the left, so solids will either settle or float. Then the water flow rate is key because you've got to keep the water in there long enough that secondary bacterial digestion will happen along the way before the water goes into the leach field, which is just a green space that soaks up the nutrients. That's tertiary treatment before your water goes back into the ground. Septic is cool because you don't need sewage handling. You don't need a wastewater treatment facility. You handle everything in-house. You still got to take that sludge to the landfill every like 1 to 5 years. But the secret with septic is the flow rate. Because you can imagine, right? If you've got rainwater spilling into your septic tank, that's just going to flush all your turds out into the leach field. Or if you live in Rincon, into the ocean. Good job, children.